Welcome to my channel where you are learning linear algebra. Imagine for a moment that today I share with you the concepts of dot product and angle between two vectors, which will take your understanding of linear algebra to the next level. Earlier we have learned why we are learning linear algebra and 5 things: vectors, distance of a point from origin, distance between two points, row vectors, column vectors. And today we are going to focus on dot product and angle between two vectors.
Suppose we have two row vectors, A is equal to A1, A2, An and B is equal to B1, B2, Bn. Let's learn some basic mathematical operations on vectors. Addition. When I add these two vectors, I get simply component-wise addition. A plus B is equal to A1 plus B1, A2 plus B2, An plus Bn. This is addition of vectors. What about multiplication? There are two types of multiplication for vectors, dot product and cross product. Just for simplicity, we don't use cross product much in machine learning, so we will not go in details what a cross product is. Let's go and understand what a dot product is. If we have two vectors A and B, dot product is written as A dot B. It's a component wise multiplication. It's nothing but A1 B1 plus A2 B2 plus An Bn. You might ask, multiplication we understand, but why addition? For now, let's define this way. We will see geometrically later. This can be written as vector notation A1, A2, An, 1 cross n, B1, B2, Bn, n cross 1. As long as this and this match, you can multiply it, right? Whenever someone says A is vector, we will consider it as a column vector. This is for simplicity. By default, it's a column vector if it's not given explicitly as row vector. Let's say I have A is equal to A1, A2, An, n cross 1, which is a column vector because default representation is always a column vector which has size n cross 1 and rows and 1 columns. Now what does A transpose mean? A transpose means basically swap your rows with columns and columns with rows. A transpose is equal to A1, A2, An as 1 cross n. I can convert a column vector to row vector by just taking transpose and this becomes 1 cross n. So going back to our previous example, what we had, A dot B is equal to A1, A2, An as 1 cross n, B1, B2, Bn as n cross 1, which is nothing but A transpose B. So we can write A dot B is equal to A transpose B notation wise. This is from pure linear algebraic perspective. Now let's understand geometrically what does A dot B mean. Let's assume I have 2D space and let's assume I have vector A and B. Of course, A has two components A1, A2 and B has two components B1, B2. A dot B can be written as norm A into norm B into cos theta. Let's assume angle between A and B is theta. So norm A is nothing but length of A, which is nothing but distance of A from origin. Similarly norm B is length of B. Now this is very useful. Now if someone gives you two vectors as A1, A2 and B1, B2, how do you determine what is the angle between them? Let's quickly see that. I can write A dot B is equal to A1 B1 plus A2 B2 is equal to norm A into norm B into cos theta. That means theta is equal to cos inverse a1 b1 plus a2 b2 divided by norm A into norm B. We have seen earlier that norm A is equal to square root of a1 square plus a2 square, which is nothing but distance of a point A from origin. Similarly for point B, if somebody gives two vectors A and B, we can easily find the angle between both of them if we just know their components A1, A2, B1, B2. What if I have two vectors A and B in two-dimensional space? Let's assume they are perpendicular to each other, which means angle between them is 90 degree. So A dot B is equal to norm A into norm B into cos 90 degree, which becomes 0 because cos 90 degree is equal to 0. So if dot product between two vectors is 0, we know that these two vectors are perpendicular to each other. This whole idea that angle between two vectors can be extended to any dimensions. Here A and B can be any dimensional vector. It doesn't matter. We can't visualize more than 3D. So if A is equal to A1, A2, An and B is equal to B1, B2, Bn, we can compute A dot B using this formula, norm A, norm B, cos theta, which means we can compute theta is equal to cos inverse A1, B1 plus A2, B2 plus An, Bn divided by norm A into norm B. If A dot B is equal to A1, B1 plus A2, B2 plus An, Bn is equal to 0, then I know that A is perpendicular to B, where A and B could lie in any dimensional space. This is the beauty of linear algebra. Linear algebra and coordinate geometry are very nicely connected through relationship like this. What about A dot A? A dot A is equal to A1 A1 plus A2 A2 plus An An is equal to A1 square plus A2 square plus An square is equal to norm A square, which is nothing but square of the distance. We have earlier seen that distance of a point from origin is equal to square root of A1 square plus A2 square plus An square. Without visualizing, we can extend the idea of 2D, 3D, 2D. That is the power of linear algebra.
In the next video, we are going to focus on projection and unit vectors. This is Gunjan Varde signing out until we meet again.